Yeah, so welcome everyone. So today the panel's on DA and the value it can capture. So I've got some wonderful guests that I'd like to welcome to the stage. So I thought I'd kick it off with a few intros to get started. I mean, some of you guys are well known by most people here, but for people who don't know me, I'm Zave. I worked at Chorus One for many years as CIO. I'm now raising for my own fund called Fractus. It's still in stealth right now, but it'll be some more news about it in the following weeks. So please feel free to reach out to me if you're interested to learn more about the strategy or the thesis, but mainly investing in pre-seed and seed stage blockchain infrastructure. So yeah, we'll hand it over to these guys to please introduce yourself.
Hello everyone, my name is Kimura. I'm a co-founder of Sunrise, that is a specialized data availability layer for proof of liquidity, severe resistance. And it also built with a PBS mechanism to capture the MA value in the long term.
Hey everyone, I'm Matt, EigenDA DevRel, part of EigenLabs, and EigenDA is a highly scalable, secure data availability layer.
Hey everybody, I'm Altan, one of the founders of Nuffle Labs. Nuffle Labs spun out a Near Foundation, and it's almost like Near Labs team, which is Pagoda, over almost like three weeks ago. Yeah, so we built pretty much Near DA. On top of that, we actually worked with EigenLayer folks to build a fast finality layer that can pretty much do cross-chain applications in 3 to 4 seconds. So.
Hey, I'm Prabal. I'm one of the co-founders of Avail. At Avail, we are trying to build a unification framework for Web3, a part of which is the Avail DA, about which we will discuss today. But apart from that, we are also building Avail Nexus and Avail Fusion. Nexus aims to be proof aggregation and sequencing layer for the rollups, and with Fusion, we want to add additive cryptographic security to the base layer. So that's
cool. So just very briefly, DA is a very hard topic. Please, could someone summarize for everyone here what DA is before we kick it off?
I mean, I can take a stab. So essentially, rollups are taking execution off-chain and then providing a proof of correctness of execution on-chain to the settlement layer. But the proof of execution need to be backed up by data availability. The data availability can take many shapes, but the most known ones are about transactional data or state deltas. So you need to publish the data behind the proofs, which you will have to verify, and that is what about data publication that is needed. On that depends the liveness or the safety guarantees of the rollup, depending on the different types of rollups and such.
Cool, thank you. So based on that, I guess there's many now DA players in the space. So I'm curious how all of you differentiate versus your peers. How do you attract customers? Is that where the value lies in DA? How do you compete with so many players in the space?
I can take that. Yeah, in general, there are different DA players, but all of them have taken different parts of the trade-off, right? So with all the differing solutions, there are different optimizations that each one of us are doing. For example, for us, the final cryptographic verifiability is very important, and that's why we are taking a KZG route. We are trying to have a nominated proof of stake with, so that the stake distribution is high, the decentralization is high, the verifiability using data availability sampling for user-level applications that we have been implementing from day one. So that is the angle that we are taking. There are, of course, very, very adept players other than us who have been, trying to optimize for example, speed by using something like a disperser, which can, propagate at a very high speed at the cost of, not having consensus on top, which can have good things and bad things, and we have discussed a little bit on that. I mean, Near has been optimizing, and Nuffle now has been optimizing on a different angle. So all of the players are taking different parts of the trade-offs. Depending on what solution you are building, we try to guide those players towards the best solution.
Cool, thank you. And I'm curious, how do you guys as well, I guess, what do you optimize for in your DA versus your peers?
Yeah, I can start. So I guess there's 3 different approaches, right? So you guys have an L1, which is just totally just doing DA and consensus. Ours has been different. So we obviously the design space we know is Near, which is a monolithic L1. And obviously, Eigen folks have a different approach where you have like tons of cryptoeconomic security on Ethereum. How do you kind of use that and do that off chain? So there's different trade-offs. And the way we kind of position ourselves is Near is like a sharded blockchain, so sharding solves for like data availability. So it's a problem that we've looked 2019, 2020, and solved that for making Near sort of viable. And the way we do it is every shard comes with a sort of throughput, and then you can add more shards along the way, increasing the throughput of the system. Alongside with that, like Near doesn't have a gas fee market. Like that's how it operates with 2 million users a day, I think. Yeah, something like that, daily active users. So we use that kind of thing to basically give cheap and high throughput scalability while also getting some sort of like billion-dollar plus cryptoeconomic security from Near. So again, it's a different approach we did, and I know that folks are taking different approaches.
Yeah, absolutely. So to speak to the EigenDA approach of, it's a data availability layer that is built as an AVS, and it does not include consensus. So the consensus for finalization is from the rollups case or an AVS's case would be the L1, let's say Ethereum that they might publish to. So we don't introduce another level there. And some of the differentiating factors are the focus on, let's say, scalability, security, and also the ability to focus on increasing latency down the line as well to expand beyond solely rollup use cases, but also expect that we'll see a lot of other services. Data that, services that you have executed, you need to be able to verify the data, or else you're working on the same trust assumptions that we build upon in Web 2. And I hope we can agree on we're looking to move towards a more verifiable, not verify, don't trust option. So on scalability, we offer 10 megabytes per second today. And the cryptoeconomic security aspect is that we enable both ETH Quorum as well as other LSTs, and then Eigen, which is used in the case of a potential data withholding attack. And we do offer the ability for custom quorum. So what I mean by that is like an L2 or a service has the ability to also include an additional quorum to stake, secure the network. And this increases the security of the system, as you're not solely dependent on potentially just one price or security model, and it can further strengthen the system rather than what we've seen in the past are these like downward pressures of price reduces the overall security of the model, and therefore continues to drive back in this negative feedback loop. So scalability beyond also roll-up use cases as well as security are, I believe, some of the aspects here and different trade-offs in the design space.
Sunrise is adopting a proof of liquidity economic security model that can mitigate some problems of proof of stake, severe resistance, and also can make engagement of the project on top of Sunrise. Furthermore, we are investigating for the attestation of the data availability of the blob data in the off-chain by utilizing the zero knowledge proof and so on. And by using the off-chain blob data availability, we can apply the data availability technology not only for rollouts but also for other data usage on decentralized application, we believe.
Cool. So there's obviously the modular stack, DA, settlement, execution, etc. So do you think DA is the most valuable layer of the stack, and if so, why?
I think if you had a different panel, they would have answered differently. Every part of the stack think that they are the most valuable. They will capture all the MEV. They will capture all the value long term. I want to kind of say that yes, we believe that's why we are building, but at the same time, it's important to understand the rationale behind it, right? So different parts of the stack capture value for different operations, and depending on what application you're building, there will be some parts which are meatier than the other in terms of value capture. For example, if you are using an on-chain DeFi application, as we know them today, there are better models that are out there for the future, but as we know them today, there is executional guarantees which are very, very meaty, and which means that sequencer layers are going to be a very valuable layer there. And the sequencers determine ordering. Although the DA can act as the ordering engine, for example, for us, maybe not for EigenDA because there are different trade-offs, but Even though DA can be the ordering engine, the sequencers take the responsibility of ordering and then they publish a batch together. In based rollup constructs, it's different because then the DA can capture both MEV and data publication costs and so on. So depending on what is the exact application, what is the orientation, what are the participants in the protocol, what kind of user intervention do we want, what guarantees do we want. So I think that will all vary. But one thing would love to kind of emphasize upon is that none of the stacks work without the data publication being guaranteed. So one of the reasons why I think all of us here are building a DA solution is because it's so fundamental towards providing any kind of guarantees for off-chain execution. There are brilliant work that is being done by all the execution clients there, optimistic ones, ZK ones, there is Wasm, there is Linux VMs, there is all kinds of stuff, blended executions and such. But all that only works if there are ordering guarantees and publication guarantees.
And so one thing that sometimes I'm confused about is like how the DA tokens actually accrue value. So there's a lot of cost savings, and so you're saving fees, etc. But how does your token accrue value from those fees that are saved for users and developers?
Yeah, I can talk to that. So for our purpose, it's always been that when we started, we established internally that we're not going to build a new blockchain. So for that reason, like the DA costs go to near, like that's the sort of the layer. Our approach has always been like, there's some value capture there, but we already started on near, so that's going to go there. But I think the question becomes that I think we start to see this with chain abstraction and everything. Like things are going up top, right? Like pumped up fund makes more money than I think it's Ethereum or Solana fees or something like that. We're thinking about more like how do we go up and build applications that feel like it's still asynchronous really, but it feels like synchronous to the user experience, and then capture fees along there, and that's where we think it's the value capture is. So DA is already like part of an existing system that's already, let's say, near the top 20 blockchain, and then we built on top that allows us to kind of capture fees along the way. And yeah, maybe pay some of them back to the actually Eigen layer restakers, and some of that we actually take as a B. So that's how we see it, and eventually, yeah, so that's pretty much allowing people to build good applications, which will eventually allow you to pay for you. That essentially becomes the gas fee model.
How about you guys? Do you differ in your approach around how your token accrues value versus like EigenLayer and near? How does your DA layer accrue value to the token itself? Because I'm sure they have different designs to each other.
Yeah, I believe it's important to maybe understand also like foundation of where, let's say, EigenDA is built upon. So EigenLayer itself is this marketplace, and if you want to view it in a mental model, it's a marketplace for trust. So a lot of these systems that we work with, we want high security guarantees. So when we talk about economic, like crypto economic security, we now have this place where we can have operators and like systems and services that begin to tap into security that you have existing, and it also can reduce maybe some of the opportunity costs that we've seen in previous models where you have to make choices. Do you want to secure your layer, or do you want to have your existing tokens that you might hold? So it adds additional utility on that front. And to speak to the token accrual, there's a couple aspects that are very important for these systems is also like the reliability and security. So I think those are like some of the largest pieces that we're going to see continue to express is we need these systems to be highly secure as well as highly reliable. And the security is really what underlies the value of these networks. We trust that Ethereum is going to be up, running, and include and reflect the accurate state of the network. So therefore, ETH has therefore also reflected that. So by providing security, you can also accrue value. So in the case of EigenDA, there are operators. I mentioned the different quorums. So the base quorums are ETH as well as Eigen, and those are staked. So paid out to the operators that are securing these networks, but also for other services that might have a custom token. They can add that additional quorum, stake that, and then earn that additional yield, and we'd be paid out in that. So the value is providing like a service at the end of the day, and in this case, it's high security and reliability. So, yeah.
I understand that the secure and low-cost data availability must go to the race to the bottom, and we are integrating probability cyber resistance, and it can capture the MAV. For example, due to the price fluctuation in the market, and to lead to the arbitrage opportunity in the liquidity pool, we can capture not only for the fee of the data availability usage, but also for other MEV. So that must be the value capture of our protocol.
Thank you. And so I guess we're still in the early days of data availability right now. How can you see the space evolve in the future? So we've talked a lot about the value accrual, use cases like AI. Is DA scalable for AI right now? Like, how do you see the space evolving?
Now you're asking me to predict future, but to be very honest, like we are right now trying to build critical infrastructure for the applications that are going to get built. What kind of applications are going to get built, it's very hard to predict. But if the infrastructure is not ready, then applications are going to suffer. And they have been suffering on the blockchain space for quite a long time. Even after we build all this infra, it's not that the applications are seamless right now. And then there's so much scope for improvement and such. Now, getting into what kind of applications are going to get built and so on, I think we are going to see a lot of app-specific chains. The trend of general purpose chains that are out there, I think there will be a few of them, of course. They would be optimizing for user capture about liquidity and such, but there will be other applications which are going to come in, and we are already seeing them. We are already seeing from social applications being app-specific chains. We have always been seeing DYDX, Immutable X. They were the OG app chains, so to say, although they were not termed as such in the early days. And those will continue to happen. The Cosmos ecosystem, you would of course know, has seen many of these app chains building, and there have been problems with getting the enough crypto economic guarantees, the security guarantees, the interoperability guarantees, and such. I think some of us are also working on that, as you mentioned. So it is going to be an app-specific world where applications will be rollups, and then it will be the interplay among them which will be the actual user experience that we are looking for.
And how is this interoperability layer right now in DA? Is it advanced? Is there still work to be done?
I mean, we are working on Avail Nexus, which aims to be the proof aggregation engine on top, because right now the state of L2 is it's very fragmented. There are not only us, there are many other players who are doing extremely good work there. Is it good right now? Maybe not. Certainly not. But it can be much better, and people are already showing the way. People like the bridges that you use today, and the aggregators that you use today, they have done very good work so that you have liquidity bridges around. You don't have to wait for 7 days for optimistic chains and such, because there is liquidity provider sitting in the middle and improving user experience. There are others which are making sure that they have a separate security assumption and still doing asset transfers and such. And this has been the case for not only the roll-up space, but all the chain space that is there. Like even for a wormhole bridge has a certain security guarantee. And when you are migrating assets from Solana to Ethereum, there are some security trade-offs and such. So it has always been there. The roll-up ecosystem is exploding, which means that newer security models are coming in, and it has to be rethought about how we are going to solve interoperability. And with Avail Nexus, we are trying to do some of that.
I can speak for interoperability. IBC compatible data availability layers such as Sunrise and Celestia let relayers of the IBC to verify the data availability through the data availability layer and run the light client to operate the messaging between rollups with IBC protocol.
Yeah, and going back to maybe what the future looks like, it'd be great to be able to predict that. As a whole, the infrastructure should be boring. What I mean by that is it should work and be consistent, and we have exposed users as a whole to too much friction. The fact that you have to have, like we talk about abstraction, and as a whole, like abstraction should win. in the sense that end users shouldn't have to care about the underlying infrastructure. And only time that infrastructure, hopefully, let's say, is exciting is it enables new use cases. It raises the floor of what's possible, but also, in existing systems, when things go down, when the Wi-Fi goes down, that's when people are talking about it, not when it's working. And we've exposed users too much to a lot of the complications, and it's awesome technology, and very excited about it, but it should be an enabler for additional applications. So like focus on like the applications and users, these appchains, these AVSs, and other uses of DA is really what this should be enabling and raising that floor of what's possible. And I hope that we can have more predictable, reliable, highly secure infrastructure that can enable applications on top of this. And that's really what I'm looking forward to the most.
Anything from you, Altan, on the future?
Yeah,
of DA?
hoping I don't get slashed for predicting the future incorrectly. But so the only one thing I'll mention is the future I see is, there's now 4 or 5, obviously DA layers. There's going to be more. I've been seeing it more like on the Solana side. I've been seeing for Bitcoin. So people will jump onto this just like in L1s and L2 games, and eventually the market will see and converge to like 3, 4 solutions. The other thing I see is obviously working with the EigenLayer folks and crypto economic security. I have a different approach than what Prabal and other folks do. They were from Polygon, which was probably still the most strong ZK sort of people that's been kind of nurturing there. For us, it's been, we use crypto economic security to do something similar. So for Aspenality, there actually kind of is the future sort of roadmap that we're going for, which is essentially dumping DA to near DA, Eigen DA, Avail DA, doesn't really matter, as long as operators can take that and provide pretty much state at the stations. So with that, you can build applications cross-chain. So that's how we see it for the future. It's, again, different approaches with how we achieve kind of similar goals in a sense.
Yeah, I think absolutely. Like in the interoperability space, there is, you have to think about crypto economic guarantees, cryptographic guarantees, what kind of risk profile are you for the users and such, and depending on that, you can custom make your application and your full infra also. Like they are optimizing for faster finality using economic guarantees, whereas we are taking a more cryptographic stance, which is going to be a slower path, and that's why it's going to be asynchronous, it's going to take time. There are different approaches, and maybe for different use cases, and we are also working with someone like a Radius so that we can have both, like we can have a faster path in synchronous composition using shared sequencer, but then once that is done, they would also need guarantees which are cryptographic, that what the guarantees that they gave to the users were actually fulfilled.
Cool. Thanks so much for your time today, guys. Where can the audience find you?
On Twitter, Avail Project is the name, and I'm Prabal Banerjee.
You can find me in Avail Unification Cup next time. So that's one. Nuff.tech is the website, and Nuffle Labs, we just got it back. It was suspended for some reason during ETC. But anyway, so you can follow us on Nuffle Labs, and yeah, I'm Mr. Altan on Twitter as well.
Too much traction you're getting.
I'll join in the cup next time.
Waffles.
Yeah, you can find us at EigenDA or build on Eigen. Feel free to reach out to me too.
Find us with the ID Sunrise Layer in Twitter X.
And I'm 0xave on Twitter. If you want to reach out, feel free to DM me, and fractus.com for my fund. Thanks so much for everyone's time today, and thank you to the panelists.